Hi, this is just a brief tutorial as you walk through Module 3, Unit 7, Section 2, the very last section. One thing that I've noticed is people are getting stuck on this section because they're not actually reading the scenario. So please make sure that you're reading all the words that come before it and even reading through the step-by-step instructions. So a swimming pool contains a fill hose and a drainage pipe. Using the hose, the pool can be filled in 2 hours. Using the drain, the pool can be emptied in 3.75 hours. Alice begins filling the pool with the hose. After 1.25 hours, she realizes that the drain is open. She closes the drain and continues filling the pool. Again, it says use a negative number to represent the rate of filling for the drain and the amount of pool filled by the drain. Makes sense because there's not anything going in. Technically, it's going out. The next question is, what is the total time it takes to fill the pool? So that's what we're going to eventually be solving for. And so the first thing it says as our directions is enter a variable and select a definition for the variable. Well, since your variable is all about what the question is about, again, and they always suggest in here a good choice would be x. You can choose x as your variable, but then again, because of what they're asking you to find, what is the total time it takes to fill your pool, when you click this in the step-by-step, makes sense that now it's time spent filling. What are you filling? Makes sense for the entire job, because it's the total time it takes to fill the entire pool. That's your entire job. So then over here in the table, what you're going to be doing in this section is you're going to again, be figuring out how to solve for x. So they give you a list of options, and again, think about what they gave you first, or what they kind of want to know. They want to know time spent filling. So that would be one of my options. We also have to know the amount of the pool that's filled, and we never were mentioned anything about the cost, so the next thing that we would have would be rate of filling. I always like to put the rate of filling to be the very last column. And if you think about your rate is sometimes like an amount divided by time, so that can also help you figure out what those two pieces would be about. So then it talks about the amount of pool filled. And you think about, okay, well, what would that be? Well, the amount you'd fill would be a pool. The time spent filling would be hours, and now your rate would be pools per hour. And then it wants to know the sort of the time or the situation. It says daily, separately, drain hose. Again, we know that the time spent filling by a drain. We know that there was a time spent while filling or emptying by a hose. And then we know that there should be a time spent filling or emptying for the entire job. So if you read the situation, it makes more sense of what those values should be. Now this makes sense, time filling for the entire job. You just wrote over here that it was x, so you enter x into your table. It will ask about the rate of filling for, in this case, for using the hose, and since it says the pool can be filled in 2 hours, and that's what she's noting down here from the problem statement, you know it takes 2 hours to fill the pool, so that would be 1 pool in 2 hours. It says the value of the time spent filling the drain is given in the problem statement. So how many hours do we spend filling sort of with the drain? Well, we spent an hour, 0.25. Our rate, again, because we know that actually up to that point, we know that it was sort of decreasing, so again, that's why they have a negative, and it's a pool. And we know that, like I said, the pool can be emptied in 3.75 hours. So we know that again from this statement as she's mentioning to us down here. The entire job, how much pool are you going to fill in the entire job? Well, you're going to do 1 pool. And now it starts to do your algebra. And if you read again what she's showing you here, this is going to help you as you do the problems in the next section. Notice if you want to find pools, you're taking your hours times your rate. So I'm actually going to take my hours, 1.25, and I'm going to multiply it times my rate, 1 over 3.75. They kind of put it in a fraction this way. You could simplify it later, but the idea is make sure you know what you're multiplying by. The next question is the time spent filling with the hose. Well, the hose is running the entire job, so that's why they tell you it's spent the same amount of time. And now again, when it talks about the amount filled, it's how long are you filling it, x, times the rate. So times 1 divided by 2. And then the last piece, how do you know what the rate is for filling? Well, it's 1 pool in x hours. This part is where it's a little bit trickier. It's trying to figure out where do you insert another expression for the cell. And one of your hints is it's typically going to be where you already have a whole number value. So I'm going to click the 1. And then again, because I know that it's going to take my entire job of using the drain, that it was put in with the drain and the amount that was put in with the hose, to get the entire pool to be filled. So again, what they're saying is I can do x divided by 2, that's the rate for my using the hose, and then technically the emptying, so minus 1.25 divided by 3.75. So it's filling the pool with the hose, the amount filled with the drain, which is really a not filling. And so that's how they get your two statements. Again, typically it's the one by the number 1, so you're just going to be setting up an equation right here. So it says enter the equation that can be solved for the defined variable. So 1 equals x divided by 2 minus my drain, 1.25 divided by 3.75. And now they're going to ask you to solve it, and this is what we've been doing in class with our last homework worksheet. You can do it by hand, or you can click the solver. Again, if you click the solver, sometimes your hints get in the way a little bit. They're going to say simplify completely, because that's just going to simplify your fraction for you. They combined it and put it over a common denominator. But you can follow your steps either by hand or follow using the solver. I'm going to multiply both sides by 2 to get rid of that denominator, and then I'm going to add the 0.6667 to both sides. So now that I've filled out my solver, I know that it takes me 2.6667 hours for the entire job to be completed. So as you're walking through your problems, just kind of remember to read through it. So as you click Go to Problem, this might be your first question, but again, read through the problem. Jennifer has 72 grams of a solution that is 19% sugar by mass. She wants to add pure water to end up with an 18% by mass sugar solution. How many grams of pure water must Jennifer add to get 18%? Enter a variable, so x. And then what do they want us to find? How many grams of pure water? So the amount of, well, which one are we trying to figure out? Amount of sugar, amount of volume, or amount of liquid? And so then you get to start clicking through, and if you know, water is liquid, and then it's going to ask, well, where? In the final solution? In the whole solution? Well, we want to know how much is added. And then after that, you're just going to start filling in. Well, we just already know amount of liquid, so that's kind of nice. What are we measuring the amount of liquid in? Grams of liquid. What else do you have in your solution? You have maybe an amount of sugar, and you probably measure that by grams of sugar. And then because they have the percentage, you have to think about, okay, which one of these would be a percentage, and it would be the ratio of sugar to liquid. And then you look through here and say which one is sugar divided by liquid. It's this one. So make sure that you go through and you read the situation as you're filling it out. Again, you may want to start off with, okay, the original solution. This one only has 3 choices. How much did we add to the solution? And then what was our final solution? So as you click through here, maybe you know how much was in your original solution. And then you could fill in all of your rates. Again, we know our original solution was 19%, so I think you could put in 0.9. Yep. You know that by the end, you're going to have 0.8. So read through very carefully as you're filling out your situations. Again, we know that we added an x, so you can put your x there. And again, it talks about Jennifer had 72 grams of solution that is 19% water, so this first one must have been 70% or 72 grams. And this is where you have to find out your grams of sugar, and what we showed in our step-by-step, it would be 72 times the 0.19. Again, you could simplify that, but I just wanted to show you that you can set it up the same way. The final solution would have to be 72 plus x on our worksheet, which means the rate here, the amount of sugar, has to be, and I'm going to put it in parentheses, 72 plus x times your final percentage. The amount of sugar shouldn't have changed from your original, so 72 times 0.19. Oops, I think I put in 70, amount of sugar if I'm adding solution, and you kind of fill that in. And if you get stuck, like what if I'm like not sure, I thought that's what it was supposed to be, it says enter the amount of sugar in the added solution. Since it says you just know that you added pure water, that makes sense why they'd say, oh wait, I didn't even add sugar. The ratio of sugar to water then would be 0. So then you're set up here, and now you have to figure out, okay, which one would I be able to write 2 solutions for? And remember, it's kind of nice to think about your final solution, but if you're not sure, you could hit hint. It says add a second expression to the cell in the worksheet. Okay, thanks. Select a cell in which you can enter a second expression that can be used to solve for x. So we only sort of have 3 cells that have an x in it. You could enter a second solution in the cell for the amount of sugar in the added solution. Like, okay, amount of sugar right where we had 0. Click insert another button. So you can keep going through and trying those different problems. So it actually said, I think when it said insert, they mentioned you could insert it here. So your original solution, if you think you added, technically it's your final solution, 0.72 plus x times 0.18, and it has to be minus what you started with, times 0.19. So you could set it up here, and then you could solve. You could probably already still set it up down here. So it says enter the equation that can be solved. So I have 72 plus x times 1.8 minus 72 times 0.19 equals 0. Times. And now they want you to solve it. And again, you can use it by hand or you could use your solver. Here, maybe it will let me simplify completely. Oh, it did. Again, if that just gets all messy, just make this screen a little bit bigger. Then I'm going to add to both sides the 0.72. Then I'm going to divide both sides by 0.18. And I find out that, wow, I only have to add 4 grams of water in order for my solution to be added. So don't be afraid to hit the hint. Notice it does make some of my escalometers go up still. But read through it, and it's going to make this a lot easier time as you're filling it out, just like any other section. Thanks.